Hello everyone and welcome in my presentation. My name is Hafsa Bousbiat and I am senior scientist at the University of Klagenfurt. I mainly work in the applications of non-intrusive load monitoring in smart homes. And in today's talk, I will be presenting my paper titled Augmenting an Ambient and Assisted Living Lab Using Non-Intrusive Load Monitoring. My work was mainly motivated by two facts. The first one is the increasing growth of energy demand and how it's badly affecting the environment, with a residential sector being responsible for more than 30% of this growth. So this points out the importance to improve the efficiency and to reduce the consumption in this specific sector. The second one is the ability of appliance level information to improve this efficiency and reduce energy consumption in households if it is provided in the right time. So the main goal of my work in this paper was to provide an affordable and easy to install energy management system within the household. And the second is to showcase some interesting use cases of energy data in the domain of ambient and assisted living and how it can improve the quality of life for the elderly people. Before digging more deeper in the content of the paper, I will just present some definitions. The first one is non-intrusive load monitoring or load disaggregation techniques, which refers to a set of methods that identifies different appliances consumption using only the total consumption in a household. And these techniques are gaining more and more importance with the big deployment campaigns of smart meters around the world. And the second one is ambient and assisted living, which refers to services and technologies that are being deployed to support the elderly people having an independent and an autonomous life with a certain level of security. The system that we proposed was deployed in the Living Lab, which is a part of the experience labs at the University of Klagenfurt. So the Living Lab is composed of a kitchen, an anteroom, and a living room, with of course different appliances in each part of the lab from different manufacturers. They are all connected to the local network using whether wireless or Ethernet connections, and they are linked through this connection to the central unit that runs at the center of the lab and monitored or managed using OpenHub, which is an open source home automation platform that helps to manage and automate some tasks in the smart home. This platform is a very interesting platform as it's an open source one, so it's costless and it has many advantages, like the ability to integrate a multitude of devices from different manufacturers and different generations. And the second one is the high security provided with the local connection, so you don't have to connect to an external network to manage your devices. And the third one is the great support of the community, so there is always updates that are being developed and offered for free to download and install in the households. So the picture shows the overall architecture of our system. It's mainly composed of a hardware part and a software part that are linked through an Ethernet connection. So for the hardware part, we used a certified European smart meter because it is intended that 80% of European customers will have a smart meter installed by the end of 2020, and this will help us to better simulate a European household. And the second advantage of this smart meter is that it has an Ethernet connection through which we can easily connect it to the local network of the lab and communicate with within the lab. For the software part, we used a Modbus protocol, which is a standard for communication between devices, and we had to extend the OpenHub with another binding that is available also as an open source solution, so that OpenHub can recognize the information that are being sent from the smart meter and communicate using this protocol. At this point of our system, we were able to visualize real-time consumption, but this was not really useful. What we wanted to have is to record the history of consumption for a period and to compare between the energy consumptions in different times of the day and different days of the week. And for this, we also extended OpenHub another time with a MySQL binding that acts as a data logger, and we linked it to a visualization tool that is called Grafana Service, and this gave us the possibility to visualize the energy evolution in real time within the lab. As I previously mentioned, one of our goals was to demonstrate some interesting use cases of this energy data in the domain of ambient and assisted living. And the first use case that we used is automatic labeling of appliances events. So the basic idea during this scenario was to simulate a real household with 35-minute duration, and then apply a non-intrusive load monitoring to detect events that are relative to each appliance. And through this scenario, we came out with two main conclusions. The first one is that different appliances result in different changes in the power, and some appliances are therefore much easier to detect because they result in a huge difference in the power, like the kettle or the oven, while others, like computers or ventilators, result in a very small change in the power, which makes it very challenging to identify them by automatic systems. And the second one is that such system can provide the possibility to reveal routines of residents if it is observed for longer periods, for example, for days or months. And this would help to identify the habits and the routines of elderly people and help to monitor them and detect if there is something wrong with their behavior. And the second one is related to this case, which is the detection of abnormal behavior. And through this scenario, what we wanted to show is that if there is a deviation in the behavior or there is something wrong within the household, it can be detected with the energy data. And for this, we used a very simplistic case, which is the fridge. The fridge, in its normal behavior, it has a periodic pattern. But when its door was opened in the second part of the chart, we can see that it resulted in an anomalous pattern caused by having this door opened, which can be easily detected by many systems. and can, for example, in a smart home, trigger alerts or trigger alarms or reminders so that the householder can react to this abnormal behavior. So the conclusion we got from this work is that open source solutions are a powerful tool to build indoor cost-efficient energy management systems, and energy data can provide deeper insights into activities in the lab, in our case, or in the household in general, and improve diagnostics, and can therefore enhance the quality of life, especially in the case of elderly people. In our future work, we would like to integrate and test different NELM techniques with our architecture, and to combine information coming from other sensors, ambient sensors of course, like motion sensors or weather information, with energy consumption data to improve the accuracy of these techniques and improve AAL solutions. Well, this brings us to the end of our talk. Thank you very much for watching. And if you need further information or wanted to reach out, please reach out through the Institute page, or you can contact me directly through my mail. Thank you once again very much for your attention.